A decorator is a function that takes another function and extends the behavior of the later function without explicitly modifying it. So we are going to define a function named decorator. Arguments will be my func, and then we will define another function inside decorator star args is the argument. Now I'll print inside decorator function executed, function executed before opening and closing braces. So this will print the function which we will be creating afterwards. We will write format and then my func dot name. Now we will just return the my func and the argument args, and then we will return the inside function inside decorator @decorator, and then we will define another function named display. Argument will be star args, and now this function is passed as an argument to the decorator function specified above after the @ sign. So we'll print in display function and then we'll print the star args, print star args, and finally we'll display, and we'll put let's say hi, how are you, and then I'll put some integer also. Let's put some integer. Okay. So you can see it is printing inside decorator function executed. So this was printed first. So we are going to define a function name greet, and then we are giving the arguments as name and message. Okay. Now we'll print hello, and then we'll put the argument which is the name, and then we'll concatenate it with a comma, and then again we'll put the message. Now I'm going to call the function greet. I'll put the name Sumit, and then the message will be good morning. So when I run it, you can see it is saying hello Sumit, good morning. So now if I'll put just one argument, let's say I'll say greet Sumit, so it will give an error. It is saying one positional argument is missing. Now if I put nothing here, then it will ask for the two arguments which is missing, name and the message. So let's take another example. Let me clear this, and I am going to take another example of add. Here I am taking two arguments a and b, and then I will print a plus b. I'll call the function add, and I am going to put some numbers here. When I run it, it is giving 66 as answer, but if I increase one argument, then it will give an error. It is saying add takes two positional arguments, but three were given, so one extra argument is been given. Now I am going to take another example of queue. Let's take an example of a queue. Let's say queue, and then I am going to give x as the argument and y equals x star x, So this will make the cube. I will return y, and then I am going to take a variable z. Inside that I will call cube of, let's say, 4, and then I will print z. So it will give the output as 64. So when I call the function, we require to pass the argument here as 4. So if I put nothing, it will give error. So we will create a class named bank account, and then the argument will be object. Now I will define a method named init. Argument will be self, first name and last name. Now I'll put self dot first name as first name, and then self dot last name equals last name. Now at the rate property. So this is a property decorator. So def full name, and then self. I'll return self dot first name plus, and then a space in between, then plus self dot last name. And now at the rate full name dot setup. Now I am going to define the method name full name self comma name, and then first name, and then comma last name equals name dot split, and then I'll put a space in between. Self dot first name equals first name, self dot last name equals last name, and then I'm going to create a if statement. If name equals name, then ACC equals bank account, and then I'll put the name Sumit, and then with separated with a comma I'll put Kumar, and then I'll print ACC dot full name, we can add another also, ACC dot full name equals, I'm going to put another name, let's say Sumit sir, Sumit, and then I'm putting sir. I'll just print ACC dot full name. So let's see. So you can see the output has been printed. So you can notice that we can access the method for our class bank account without parenthesis. This is because of property decorator. In this video we will be learning about variable function arguments. We will define a function that can take variable number of arguments. So here we are taking an example of default arguments. So we are going to define a function named greet, and the argument will be name and MSG, and we are going to put good morning as the message, and then we'll print hello, and then we'll put the name, and then we'll put a comma. Again we'll concatenate it with the message. Now I am going to call the function greet. So here you will notice that I am just using one name like Bhishma. Okay, only one argument is given, and again I'll put two arguments and I'll change the message here. Let's say Duryodhan. Okay, and I am going to change the message as how do you do. Okay, and now I'll greet, let's say Karna, and then I'll change the message as good night. So let's see the output. So you can see the output. So now we'll take the example of keyword argument. So here I am going to define a function named, let's say, add two numbers. So arguments will be num1 and num2. So this is the example of keyword argument. Okay, and now I'll put total equals num1 plus num2, then I'll return the total, and then I'll just print add two numbers. So here the order doesn't matter. You can put, let's say, num2 in first place. Num2 is equal to, I say, 70, and num1 equals 43. So when I print it, you can see it is printing 113 as the output. So the next one is the arbitrary arguments. Okay, so we use arbitrary arguments when we do not know how many arguments is required. So we will use asterisk symbol or star. So here I am going to create a function named greet, and then I'll put star names, and then I'll put a for statement for name in names, then I'll print hello, and then I'll put name, and then I'll just greet how many persons I want. I'll put here Yudhishthir, then Arjun, Bhim. Here I can put as many arguments I want, so I am putting one more, let's say Nakul, and then Sahadev. So when you print it, you can see it is printing all the arguments. So now let's take another example of addition. Okay, so I'm going to put star numbers, and then total equals 0, then for number in numbers, total equals total plus number, then I'll print sum is, and then I'll put the total. Now I'll call the function. So I'm not giving any argument, and then addition, and then here I am going to put, let's say, 3 arguments, and here again when I call I am putting different arguments, let's say 50.11. so when I print it, you can see in first one it is taking no arguments, that is 0, and then again in the second one it is taking 3 arguments, and in the last one it is taking 5 arguments. In this video we will be learning about recursion. So recursion is a function that calls itself again and again. So I am going to define a function name factorial, n is the argument, then I'll say if n equals 1, then return 1. So our recursion ends when the number reduces to 1. This is called the base condition. Every recursive function must have a base condition that stops the recursion, or else the function calls itself infinitely. I'll put a else statement here, else I'll return n multiplied by factorial of n minus 1. So you can see I am calling the factorial from inside the function. So when we call this function with a positive integer, it will recursively calls itself by decreasing the number. So each function multiplies the number with the factorial of the number below it until it is equal to 1. So I'll just put a variable name num equals 3. So what it will do, it will multiply 3, 2 and then 1. So that will give the output as 6. So I'll print the factorial of and I'll put the num and then is and factorial of num. So let's see the output. So you can see the factorial of 3 is 6. So let's change the num to 6. So it will give the output as 720. So you can see it is giving the output as 720. In this video we will be learning about DataFrame head and tail function. So the DataFrame head function is used to see the first n rows of the data frame. So by default it shows the 5 top values of the data frame, but we can change the values. So let's take an example. So we are going to import Pandas as PD, and let's make a dictionary student underscore dict. Okay, now I am going to add some values inside it. So let's say name, and then I am going to add some names inside it. So let's say the names are Kumbhakaran. Okay, I have given one extra quotation mark over here. So let me do another one, Indrajit, and again Meghnath, Sukhveer, and let's say Bali, again Jatayu, and again one more name, let's say Jambavan. Okay, these are the 7 names we have given. So now I am going to put some age inside it. So I am giving age as let's say 20, 21, 19, 17 and 18, 19 and 17. So these are 7 ages, and again I am going to give some marks. Okay, so marks will be like 85.10 and then 77.80 and then let's say 91. Again I am going to give 87 and then 90, 1 2 3 4 5, and then I am going to give 7, let's say 94 and 91. Okay, so these are the 7 values. So we are going to create a data frame student underscore df equals pd dot data frame, and then we are going to put the student underscore date. Okay, now we will display the first 5 rows. So top rows equals student underscore df, and then we will make the head function. So it will call the first 5 rows. So we'll print the top rows. So when I print it, I can see the first 5 rows from the top. So now let's select top n rows in Panda data frame. So we'll just change the value over here. So let's do that. I'm copying it and pasting it here. I'm putting the value 3 over here. So it will show the top 3 rows. So now let's change the value to -2. So you can see it is printing the first 5 rows and it is not showing the 2 values. Last 2 values it is not showing. So now let's select some top rows from multi-index data frame. So we have to make a multi-index data frame. So let me make that index equals pd dot multi-index, then from tuples. Okay, and I am going to put some values inside it. Let's say standard 1, and then I'll put class 1. Let's say class 1, and then I'll just copy it and paste it again, so you can save some time. So I'm going to put here class B, and standard it will be 1. It is class A, and now I'll put a comma and just paste it. It is class A and standard 2, and then again I'll paste it, class B and standard 2. Similarly for third one also I'll do like this. Standard 3 and class A. Similarly standard 3, class B. Okay, so the bracket is closed, and now I'll put a names equals standard and class. Okay, so this is our multi-index data frame. Multi-index, so we will convert it into columns equals pd dot multi-index, and then from tuples, and then we'll put names and surname. Okay, names and surname. Now I'll put marks and percentage and percentage. Okay, now we'll create the data frame. Student underscore df equals to pd dot data frame, and then we'll put the values as name and percentage. So let me put that. I'll put the name as similar to the above, Kumbhakaran, and I'll put some values. Let's say 67. Again I'm going to put the value of Indrajit and the percentage as, let's say, 80. Similarly for Meghnath, okay, value will be 75. Similarly we'll do for the other values. Let's say Sukhvi, the value will be 87. Bali 90, and then let's say one more name, Jatayu. So Jatayu, the value is 94. Okay, so this is our data frame. So we'll put a index and column also. Index equals index, and then columns equals columns. Okay, so now we'll just make a variable top rows equals student underscore df dot head. So this will show the values from the top rows. Okay, so when I print it, I can see the top 5 values: Kumkaran, Indrajit, Meghnad, Sugriv, the percentage of the respected name, and the values associated with it. So let's use the tail function. So it is similar to that, but it will show the values from the bottom. So let's copy this. So we'll use the same data over here also. So data frame tail function. Okay, so this is our values. So we'll just print the bottom rows. Okay, equals student underscore df dot tail. So this will show the bottom rows. So we'll print the bottom rows. Okay, so you can see here it is printing from the bottom. So now let's change the value, and let's say we put here 3. So let's copy this and we'll change the value so that it will show the custom rows. So let me put here 3. So it will show the bottom 3 values. So you can see here it is showing bottom 3 values. So when I put -2 over here, so it will show the all the values, but first 2 values will not be selected. So similarly, we will select bottom rows from the multi-index data frame. So let's select this multi-index data frame we have created above. So we are taking the same data over here. Okay, and now let's say select bottom rows from the multi-index data frame. Okay, we'll paste it, and similarly we'll do like the above case. We'll just put the bottom rows variable equals student underscore df dot tail. So this will show the bottom values. So we'll print the bottom rows. Okay, so you can see here it is showing the bottom 5 values. So now we'll select the value of row and column labels using the data frame AT function. So AT function we are using. It is very interesting one. So now we'll just copy it so that we don't have to type. So we'll select the first student data. So it will be similar to that. So now we'll put a value variable equals student underscore df, and then I will put the AT function, and I will just select the second row and the label as age. So this will show the value of second row age label. So I will print the value. So you can see the value is 19. So you can see here this value is being printed. So now we'll set specific value in Pandas data frame. So we'll set some value over here. So the value is 19. So we'll change it to something else. So let's say student underscore df dot at, and then we will change the value of second value of age index. to, let's say 50. We'll change the age as 50. Let's print the value, print student underscore df dot 80, and then we are going to see the second value of age. Okay, so you can see here it has been changed to 50. So similarly we'll select values using rows and column position using IAT function. So you can also select the rows and columns like this. So let me copy and paste this, and we'll change the value. I am going to put here IAT function. Okay, so now we will just change the value. So before changing, let's see the value. Value is equals student underscore df dot IAT, and then we are going to see the first row and second column. So we'll print the value. So you can see here it is showing the value as 77.80. This value is being shown. So let's change this value. So for changing it, we'll just use the student underscore df dot IAT 1,2 equals 90. Okay, so we'll print the student underscore df dot IAT 1,2. So it will be changed to 90. So this was our head and tail function. In this video we will be learning about data frame modification. So let's start with applying some filter. So for that we will be using data frame where function. So for that we are going to import Pandas as PD, and then I am going to make a student dictionary, student underscore dict equals, I am going to add the values inside it. Let's say name, and that inside name I am going to put Savari Kandu, and let's say Vritasur. Okay, these are the three names. Another will be age. Let me add the age here. Age will be, let's say 22, 24 and 19. So these are the three age. And last one will be marks. So let me add the marks. (76), 85, and then 91.7. So these are the values. Now let me create a data frame. Student underscore df equals pd dot data frame, and then student underscore dict. Okay, now we'll apply the filter. So the filter will be, let's say marks student underscore df, and we'll put the marks as the filter, and then we'll put above 80. So below that will not be considered, and it will be written the value 0. So student underscore df, and then marks, and we'll use the where function, where filter, and then other equals 0. Okay, and then in place is equals to, now we'll print the value, print student underscore df. So you can see the value below 80 is being showing as 0. So now let's apply filter in the columns. So for that we are going to simply write student underscore df equals student underscore df dot filter, and then like equals n, and then the axis will be columns Okay, and now we'll print the student underscore df. So you can see it is showing the names column because we have applied the filter. So now let's rename a column. So for that we have to copy this because already the data has been changed here. So we have to copy and use a new one. So I'm pasting it here. Now I'm going to rename student underscore df equals student underscore df dot rename, and then column equals column equals, we'll put marks as percentage. Marks is will be changed to percentage. Okay, so it will be changed to percentage. We'll print the student underscore df. So you can see the marks column is now changed to percentage. So now let's join. So for that, let's say join a data frame. Okay, so for that we'll paste the same thing, and we will, let's say, remove the marks column from here, and we'll make a new one to join. So I'll completely remove that one, and now I'm going to make a marks underscore dict. So this will be joined equals, so the new marks will be put here, marks equals, colon will be given here, and then I'll put the new marks as 77, 92 and 85. Okay, so these are the new marks. Now let's change this to a data frame. Marks underscore df is equal to pd dot data frame, and then we'll put the marks underscore dict inside it, and let's print it to see if everything is alright. Marks underscore dict, so everything is fine. The new marks dict has been created. So let's join it. So joined underscore df, this will be a joined data frame, student underscore df dot join, and then we'll join the marks underscore df. Let's print the join df, join underscore df. So you can see the new mark has been joined to the data frame. So now let's group by a column. So we'll add a new column. So let's group by. Okay, so we'll paste the about data, and we'll change the, let's say we'll change the age by class. Let's say class will be C, and then A, and then let's say B. So these are the classes. So let me change this to class. Now I'll just group by class. So student underscore df equals student underscore df dot group by. Okay, it will group by the class. Okay, so it will group it dot name, and I print it, print student underscore df. So you can see it has grouped it by A, B and C. So now let's iterate through the data inside the data frame. So iteration, let's say data frame iteration. So we'll simply make a for statement for, and then we'll put the value for index, comma, row in student underscore underscore df dot enter row, and then we'll simply print the index and the row. So let's run it. So I just missed the x over here. So you can see it is showing first as this, second as this, and third as this by iterating through the rows. If I paste this, it will change the value as different. So let me copy the above value to make it a little easy to differentiate between the iterative values. So you can see here it is showing the Sobri age and marks, Kandu's age and mark, and then finally Vritasur's age and mark. So let's do some sorting. So let's say sort. Okay, so we'll paste the above data, and here we will be sorting through the marks. So we'll let's say student underscore df equals student underscore df, and then we'll sort the values as by marks. Okay, so we'll put the marks inside it. So when I print it, it will be sorted by the marks, student underscore df. Okay, so you can see it has been changed to the sorted values. So it was already sorted, so we can change the values and see. So let's say I am changing the value to 80, let's say 86, and here I am going to make 77 point this. So let me change it. So you can see here it has been sorted by the values. So now we'll see the data frame conversion. So we'll change the data frame to dictionary. So if we have a value in the CSV file, so we can change the CSV file to again data frame value to CSV values. So here we will be changing the data frame to dictionary. So we already have the data frame over here, so we'll just convert into the dictionary. So I'm going to make a variable dict is equal to student underscore df dot toDict function. So this will be converting it to dictionary. So print the dict value dict. So it is saying an error because I have missed the underscore over here. So when I run it, it has been converted to a dictionary. In this video, we'll remove columns from data frame that contains missing or NA values. So we'll use the drop NA function over here. So I am importing Pandas as PD. Again, I am going to import Numpy as NP. So we have covered the Numpy library also. Student underscore dictionary equals, now I'll add some names. Let's say no, and then okay, let's add 4 names and okay. So now we'll add a column age, and then we'll put some age inside it. Let's say 22, 35, 43, and let's say 23. Okay, so these are ages, and let's put some marks. 85.90, and I am going to put some NA values by using np.nan. Okay, so we have inputted 2 NA values. So finally I am going to put 90. Okay, So now we'll print. So before printing the dictionary, we'll just make it a data frame. So student underscore df equals pd dot data frame. Okay, and then we'll put student underscore dictionary. Okay, so our data frame is ready. We'll print the data frame before dropping column na. Let's put a next line and our data frame student underscore df. Okay, so let's see. So here some I have forgot to put the semicolon over here. Okay, so you can see this is our data frame. So now let's drop the column with na value. Okay, so we'll put student underscore df equals student underscore df dot drop na function, and we'll put the axis as column. Okay, columns. Then we'll just print the student df after dropping column na, next line, and student underscore df. Okay, so we'll run the program and we can see here the column marks had na values, so it has removed the column. So now we'll drop column where all values are missing. Drop column where all values are missing. Okay, so here we can drop an empty column with data frame using drop na. Okay, the same function. So we'll just copy the above data to save our time. Here I am going to just change the each column with na values. So here na dot np dot nan, np dot nan, 35 also be converted to np dot nan, and in 22 np dot nan. Okay, so this is our new column of age with na values inside it. So we'll just remove that. Student underscore df is equal to student underscore df dot drop na. Okay, then axis will be column, and then how equals all. So all the values should be na to be removed. Print the student data frame after dropping column na student underscore df. So the each column has been removed because all the values were na. So now we'll drop columns with number of na. So while cleaning the data set, we can keep the columns with at least some data available in it, else drop otherwise. Okay, so we'll be copying the above data and I'm just pasting it. Okay, and then I'm going to put student underscore df equals student underscore df. Okay, then drop na function, axis will be column, axis equals column, and then we'll use thresh equals 3. Okay, so here it is clear that name doesn't have any na value. So what this thresh equal 3 will do, it will keep column with 3 or more non-na values. So the above data which we have copied, so in that age also doesn't have a na value. So we'll just print the student df after dropping column na. Okay. So you can see the marks had two NA values, so the column was removed, but here in age and name there was no NA value, so it is being printed. So now we'll drop NA value from defined rows, so we'll define using subset. Okay, so let's paste the above data. Okay, and now I'm going to put student underscore df equals student underscore df dot drop na. Axis will be column, axis equals column, and then we'll put subset equals 0 to 2. Okay, and then we'll just print the data frame after dropping column na student underscore data frame. Okay, so let's print it. So you can see marks had na value, so it is not printing that. So let me change one na value to some number, so let's say 77. So now when I am printing it, so it is printing the value because it now has only one na value. In this video we will reset the index of the pandas data frame using the reset index function. We will be importing pandas as well as numpy. So import pandas as pd and then import numpy as np. Okay, so we have imported these two libraries, so we will be using student underscore dictionary. Okay, so let's create it. I'm going to put a name. Okay, so name column will contain some names, so let's say Rushali, Supriya. Okay, and let's add a na value np.nan. Okay, and then we'll add another name, let's say Uruvi. Okay, so these are values for name. So let's add age. Okay, so age will contain 20, 21, np.nan for na value, and then 22. Okay, now let's put some marks. So marks will contain 85.10. Okay, let's say 89.99, and np.nan for na value, and then 90 for the last one. Okay, so let's create a data frame. Student underscore df equals pd dot data frame, and then we'll put the student underscore dictionary. Okay, and let's make an index equals s1, s2, and s3, s4. Okay, so this is our index. So let's print the original data frame. Print original data frame. Okay, slash n and student underscore df. Okay, so this is our original data frame, and you can see here in the index s3 we have na value. So let's remove that by using drop na function. Okay, so for that student underscore df equals student underscore df dot drop na function, drop na. So this will drop it. So let's print it. Data frame after dropping NA. Okay, so let's put /n for next line, and then our data frame student underscore df. Okay, so you can see here the S3 is been removed because it contained the NA value. So now let's reset the index student underscore df equals student underscore df dot reset index. Okay, so this will reset the index. So let's print the output data frame after resetting index. Okay, /n for the next line and our student underscore df. Okay, so you can see here the index has been resetted from 0, 1 and 2. Okay, so now we'll reset the index without new column. So this column index which contain S1, S2 and S4 will be removed by using the drop. Okay, so we'll use the above data because it is same, otherwise we have to type it once again. Okay, so we are just copying it till the drop NA function. Okay, let's paste it. So you can see here we have the data. Now let's reset the index and drop the column student underscore df equals student underscore df dot reset index, and then we'll drop equals true. Okay, let's print the final output data frame after reset index /n, and then let's put the student data frame. Let's wait for some time. So you can see here the index has been resetted and the column of index is being removed. So now we will reset the index and start from 1. So reset index starts from 1. Okay, so we will be using the same data as above, and then we'll just increment the index. So student underscore df equals student underscore df dot reset index. Okay, so this is our reset index function. Now just increment it by 1. Student underscore df equals index equals student underscore df and then index, and then we'll increment it by 1. Okay, now let's print the after reset index /n. Okay, and we'll put our data frame student underscore df. So you can see here the index is starting from 1, 2 and 3. So similarly we will reset the index to the range of numbers. Okay, so let me put a comment, reset index to the range of numbers. So we are pasting the above data and we will be using the range index here. So student underscore df dot index equals pd dot range index. Okay, and then we'll start it from, let's say, 101. Okay, it will start from 101 and it will stop at 101 plus the length of the data frame, so student underscore df. Okay, and then let's put a step equals 1 step. Okay, everything is all right. Yes, and then we will just print the after reset index and our data frame student underscore df. Let's see. So you can see here the index is starting from 101 and then it ends at 103. So now we will reset the index and change the column name. Reset index and change column name. Okay, we are pasting the above data and we will just use the reset index function and rename function. So student underscore df equals student underscore df dot reset index. Okay, and then we'll put the rename and we'll change the column name. Okay, columns equals, so let's say we'll change the index column index to, let's say, id. So this index will be changed to id. So let's print it. Print after reset index /n and then our student underscore df. Okay, so you can see here the index has been changed to id. In this video we will learn about DataFrame metadata. Sometimes we need to get metadata of the data frame and not the content inside it. Such metadata information is useful to understand the data frame as it gives more detail about the data frame that we need to process. So let's import Pandas as PD and we'll make a student dict. So it will contain the values, let's say name, and the name value will contain the names Panchali and Subhadra and Uttara. Okay, these are the three names. Now the age will be, let's say, 20, 21 and 18. These are the three ages, and we will give the marks as well. Marks, and the marks will be, let's say, 90 and 91.70 and 89.06. Okay, these are the values. Let me close the bracket. Now we will create a data frame from dict. So for that I will use student underscore df equals pd dot data frame and then I'll put the student underscore dict inside it, and now I'll print the student underscore df. So here it is PD. So you can see it is showing the values inside it. So let's see the info inside it. So I'll be using student underscore df and then dot info. So this will give the info. So you can see it is giving the info as data type count. So you can see float 64, int 64, and object is the data. So now let's see the other values. So we are going to print the student underscore df and then describe. So it will give many values. So you can see here it is giving the count, mean, standard deviation between the data, minimum 25 percentile, 50 percentile, 75 percentile, and the maximum value. So let's see some other attributes as well. So let's print some data. Print data frame index, and it will show the index of the data frame. So student underscore df and then index. So let's print this. So it is giving the index of the data. It is starting at 0, stops at 3. Similarly, we will do for the column as well. So let me copy this. So I am going to change here as columns, and here also I will write columns. So you can see here it is giving the details of the column name, age, marks and data type. So similarly we will type the column type. So I will do here as data type D types, and then I'll write here types. Okay, so you can see here it is saying int 64 and float 64. Similarly, let's see if the data frame is empty or not. So I'll write here data frame is empty question mark, and then I'll just put here empty. So you can see here it is giving false. So let's see the shape of the data frame. So I'll write here shape, and here also I'll write shape. So these are the shape 3,3, and similarly I will see the size of it, size. So let me write here size. So it is saying 9 is the size. So let's see the values of the data frame. Value, and then here also I'll write values. So you can see here the values are also given here, the name, age and the percentage. So similarly you can do the selection also of the data frame. So let's do some selection in the row. Let's select the top 2 rows. So I'll print student underscore df, and then I'll print the top, so it will be head 2. Okay, so when I print it, I can see it is giving the top 2 values. Similarly I can write for the bottom also student underscore df dot tail, and let's say 2. Okay, so it will give the bottom 2 values. And now let's select value at row index 0 and name column. So I am going to print student underscore df and then 80, and then I'll put the 0 and name. Okay, name. Now let's print it. So you can see it is giving the name value as Panchali at 0th position. So similarly we will select a value at first row and first column. For that I will print student underscore df dot iat, and then I'll put 0, 0 for first row and first column. Let me close the bracket here. You can see it is giving Panchali. Similarly we will select the name column. So I'll print the student underscore df then dot get, and I'll get the name values, name, here the caps lock was on, so I have to change this, student underscore df. So it is giving the name value and the name object. So you can see Panchali, Subhadra and Uttara. Similarly we will select the value from row index 0 to 2 and then the name column. So I'll print student underscore df dot loc, and then I will write the slice of 0 to 2 and then the name. Okay, name. So when I print it, I will see the name. Similarly, we'll select from row index 0 to 2. So let's print student underscore df dot iloc, and then I'll put here 0 to 2 and then similarly 0 to 2. So you can see here it is given the value of name and age. So you can also modify the data frame by inserting columns by using the insert function. So let's do that. Let's say student underscore df and then insert, we'll insert at loc equals 2 and then we'll add a column equals class. Okay, class, and then we'll put the value as a for all, value equals a. So this will put the value of a. Print student underscore df. So you can see here it has added a new column class and then the value as a. Similarly, we can drop columns by drop function. So let's use that. Student underscore df equals student underscore df, and then we'll put the drop function and I'll drop the column class which I have newly created. Columns equals, let's say, class. So we'll drop this and we'll print the new student underscore df. So you can see the class column has been dropped. In this video we will learn how to convert Python list to Pandas data frame. So let's import Pandas as pd and then we'll create a list, fruits underscore list. So we'll add some fruits name inside it. So let's say apple, and then I'm going to add another name as, let's say, orange, and we'll give here 77.77. Okay, now we'll print the fruits list. So when we print it, we can see the list has been printed. So let's create a data frame from the fruits list. So we'll write fruits underscore df equals pd dot data frame, and then we'll add the fruits underscore list. Okay, now I'll print the fruits underscore df. So you can see it has been converted to data frame. So now let's create a data frame from list with a customized column name. So custom column name. Okay, so we'll add a custom column name over here. So we'll make a fruits underscore list and let's add fruits name apple, it's a banana, and orange, mango. So these are 4 fruits, and now we'll make the fruits underscore df and then pd dot data frame, and then we'll add the fruits list inside it, and then our column name, columns is equals, we'll add fruits. So this will be our column name. Now let's print fruits underscore df. Okay, so here in line 10 there is an error. So let's see what's the error. Data frame fruit lists columns, so we have missed the L over here. So you can see the column name has been added. So now let's create a data frame from list with a customized index. So we'll give some index name to the columns. Okay, so customize index, custom index. So let's create a fruits underscore df equals pd dot data frame, and then we'll put the fruit list inside it, and then we'll add the index. So let's name the index as fruit1, and then let's say fruit2 and fruit3, and then finally fruit4, because there are 4 fruits over here, so we have named it as till fruit4. Now let's print the data frame fruits underscore df. So you can see the index have been given fruit1, fruit2, fruit3 and fruit4. So now let's create a data frame from list by changing the data type. So let's change the data type, changing the data type. Okay, so let's create a list as price underscore list, and let's put some price over here. Let's say 50, 100, and then let's say 60 and 120. Okay, these are 4 prices. So let's create a price underscore df equals pd dot data frame, and then we'll add inside the price list, price underscore list. Okay, now we'll print the current data type. So data type before. Okay, so this will be the data type before. So price underscore df dot d types. Okay, this will be the current data type. So now let's create a data frame from list with type change. So price underscore df equals pd dot data frame, and then we'll put price underscore list, and then we'll change the data type to, let's say, float 64, float 64. Okay, now let's print the data type after data type after. So this will print the change data type. So price underscore df dot d type. Okay, so let's print the price underscore df. Okay, so you can see it is giving the data type as object, and then it has been converted to float 64. Now we'll create a data frame from hierarchical list as row. So df from hierarchical list as row. Okay. So now we'll create another list. So fruits underscore list equals, we'll put the data inside, let's say apple, banana, orange and mango, and let's put the values inside it. So let's say 120, 40, 100 and 50. These are some values. So now we'll first we'll print it. Let's see what the fruit list contain. So you can see there are 2 lists inside it. So now we'll just create a data frame fruits underscore df equals pd dot data frame, and then we'll put fruits underscore list, and just we'll print the fruits underscore df. So you can see it is printing like that. Now we'll create a data frame from hierarchy list as columns. So we'll use a transpose function inside it. So let me copy this and change it to the column. Okay. So we'll create a data frame. So we already have the fruit list. So we'll just create the data frame fruits, or we'll just copy it so there will not be any error or change in data if there is any. So fruits underscore df equals pd dot data frame, and then we'll just put the fruits underscore list, and then we'll use the transpose. Okay, and then we'll print the fruits underscore df. So you can see it is giving the output as this. It has transposed the columns. So we'll create a data frame from multiple lists now. So we'll use a zip object over here. So the zip function will convert it into a zip object. Now let's create a, let's say we'll use the multiple list. So df from multiple lists. Okay, so we'll create a list over here. So we already have the list, so we'll just paste it and make it multiple list. So I'll just change it to price underscore list. So this will be the price. Okay, so we have two lists over here. So we'll just convert it into a data frame. Fruit underscore df equals pd dot data frame, and then we'll use the list and zip function, zip, and then we'll put it inside fruits underscore list and the price list, price underscore list, and we'll put the column name. So columns equals, first we'll put the column name as names, and then second will be price. Okay, so these will be our column names. So we'll just print the price fruits underscore df. So it will, so there is an error, price underscore list is not being 44 price underscore list. So there is a problem inside this price underscore list because I have given an extra bracket over here. So now you can see it is giving the correct output. In this video we will be learning about indexing. So I am going to import Pandas as pd, and then I'll put df is equal to pd dot data frame. I am going to take values with different data type. So I am going to take a as 1, 2 and 3, and now b as some boolean values. So I am going to take true, and then false, and now I am going to take another one, c, as some floating point numbers. So let's say 0 point, and then another value, let's say minus 0 point, and 0 point. So these are our values, and I am going to take index is equal to ABC, okay. So these are values. So let's print the values of df. So when I am printing, so it is giving the values. Now we'll index it. So let's say I am printing df and then a. So it will print the values in the a. So it is giving error because I have not given the quotation mark. So now it is giving the values in a column. Now I am going to make a variable, let's say calls is equal to a comma c. So these are values. So when I print df of calls, so it will print the values of a and c. So likewise we can do for rows also. So we have to use LOC for that. So printing df dot LOC, and then I am going to put the values of a and b. So it will print the values of index a and index b. So similarly we can use ILOC for indexing through zeros and ones. I am giving you the example. Print df dot ILOC. So it will be using the index 0 and index 1. So when I print, so it is giving like this. Let's say index 1 and 2. So it will give the values of index 1 and 2. So similarly we can also use this one like slice. So this will give the same output. We have to delete this. Now it will give the same output. Similarly I can also use like this, print df dot LOC, and then I will give a and capital B. So you can see here it is giving the value as true because the value of a and the b is true. So it is giving like this. So we can also use like this, print df dot LOC, and then I am going to put a and then b, and then I will be giving a and c, a comma c. So you can see it is giving the values. Now we'll see about the series. So each column in a data frame is in some sense is a series. So we can select a series from the data frame in a few ways. So let's do that. Let's say print df, and then I am going to print the values of a. So it is giving the value of a, you can see here. Now I will use the LOC. So print df dot LOC, and then I am going to put the values of a. So it will print the complete value of a. Similarly I can use simply a. Let's say print df dot a. So it is giving the same output. So now I will take df and then mean and then equals, I will put the value a comma b comma c, and then I will print df. So when I print it, I can see the values. In this video we will learn how to set the index of the Pandas data frame using the existing columns or a list of labels. We will start with setIndex function. So let's import Pandas. pandas as pd. Okay, we have imported pandas. Now we'll make a student dictionary. Okay, inside that let us put some name. Okay, let's say Sridhama. Okay, Subala, and let's say Sudama. Okay, these are three names. Let's put some age. Okay, 20, 21, 22. These are ages, and let's put some marks. Okay, marks are as follows: 85.10, and let's say 89, and then 91.54. So this is our student dictionary. So let's create a data frame. Student underscore df equals pd dot data frame. Okay, then we'll put the student underscore dictionary. Okay, so let's print it and see if everything is correct. Before set index, let's put a slash n for next line, and then our student underscore data frame. Okay, so you can see here the index is 0, 1, 2, name, age, and marks. Okay, so let's put set index over here. So student underscore data frame equals student underscore df dot set index. Okay, and then let's set the name as the index. Okay, let's print it. Print after set index underscore data frame. Okay, so you can see here the name has become the index now. So we will set an index using a list. So we'll use the above data only. So I am copying this data. Okay, copied, and then I'll paste it. So before that, let me put a comment: set index using a list. Okay, I pasted the data. So let's make a index variable, index. Inside that pd dot index, and then I'll put s1, s2, and let's say s3. Okay, so this is our list, and let's put the set index student underscore df equals student underscore data frame, and then set underscore index, and then we'll put the index inside it. So let's print it after set index. Okay, student underscore df. So you can see here the index is now s1, s2, and s3. So let's set index using multiples column. So set index using multiple columns. Okay, so I copied the data and pasted it, and we'll just set the index now. Student underscore df equals student underscore df dot set index, and then we'll put, let's say, marks. Let's say first we'll take names. Okay, names, and then let's put marks. So if you put marks also in the first, it will not make any issue, but it will show differently. Let me show you after printing it. After set index, okay, and then slash n. Oh my god, slash n. Okay, and then student underscore df. There is some print mistake over here. it is name. Okay, so you can see here name and marks and age is separated. Now we will set index using a list and a column. So set index using a list and a column. Okay, so what we will do here, the data will be same, we'll just use the index and a column. Okay, so just like above, we are making an index equals pd dot index and then the data, let's say s1, s2 and s3. Okay, and we'll use the set index student underscore df equals student underscore df, and then we'll put set index and then we'll put the index and the column name. Okay, so let's print it and see the output after set index. Okay, so you can see here the index s1, s2, s3 and the column as name. So we'll set multiple index using two Python series now. So let's do that. Let me put a comment first. Setting data, setting set multiple index using two Python series. Okay, so we'll use series over here. So the data will be the same, will not do anything to the data. We'll just make a s variable. Okay, s is equal pd dot series and then let's put the series as 1, 2 and 3, 1, 2 and 3. Okay, and student underscore df equals student underscore df dot set index, and then we can do like s and square of s. Okay, it's like this. So let me print it. Print after set index underscore DataFrame. So you can see here the first index 1, 2, 3 and the square of it 1 square, 2 square and 3 square, that is 1, 4 and 9. So now we will set index using a Python range. So set index using Python range. So you are familiar with range. So let's do that. We are pasting the above data. Okay, I am just index over here. Let's say the like the above one index. Okay, index equals s1, s2 and s3. Okay, so now we will just make a index variable over here. Index is equals pd dot index and then let me put the range inside it. Let's say 1, 4, 1. Okay, so this is our range. Student underscore df equals student underscore df dot set index, and then we'll put the index. Okay, so let's print it. Print after set index student df. So here is our output with range. Okay, so now we'll set index but keep the column. So the column will not be removed. but the index will be there and the column will also be there. So set index but keep column. Okay, so we are using the same data. We'll just use the drop function as false. So student underscore df, and then I'm going to use student underscore df and then set index, and then we are going to put name, and then we will say drop is equals false, so it will not drop the column. Okay, so print after set index student underscore data frame. So you can see here the name is also there and the column is also there and the index has been set as name. Okay, so now let's set index by keeping old index. Okay, so we'll use append over here. Okay, so I have pasted the above data. Let me put an index over here. Index equals, let me put s1 s2 s1 s2 and s3. Okay, I will just append it with true. Student underscore df equals student underscore df dot set index, and then the column name will be name, and will append to. Okay, so let's print it. Print after set index data frame. Okay, so you can see here the old index s1 s2 s3 is there. In this video we will be learning about Python Pandas. So it is a package that aims to be the fundamental high level building block for doing practical real world complex data analysis in Python. So we'll start with Python DataFrame. So DataFrame is the most widely used data structure in Python Pandas. You can imagine it as a table in a database or a spreadsheet. So let's take an example by making a dictionary of student. So I am making student underscore dict equal to, I'll put the name of the students. So let's say name, and then we'll put the name of the student inside it. Let's say Karna, and the next name is Arjun, and let's say third is Bhim. Okay, so these are the three names. Now we'll put the age. Let's say age is 30, 25, and let's say 34. These are three ages of three people, and let's say the marks equals, marks is 85, and then I'm going to put 90 and 87.65. So this is our data. So when we print the student dict, so we will see value like this. So now we will see what Pandas can do. So we will just import Pandas as PD. Okay, now we'll create a data frame for dict. So student underscore df for data frame equals PD dot data frame, and then I'm going to put student underscore dict, and then I'll print the student df. underscore df. So here you can see the pattern in which it is been printed. So you can see the name, age and mark. This is the header, and this is the row, and this is the column. So now we'll take another example, so it will be clear for you how this is working. So now we are going to simply make a df equals data frame. So pd dot data frame, okay, and then we'll put the data inside it. Let's say x, and then we'll put some values inside it, 12, 67, 89, 90. So these are the 4 values. Let's take 5, 45, and then we'll take y, and we'll similarly put the values of y also inside it, 65, 76, 87, 43 and 65. And next we'll take z, and we'll put the values of z as 87, 34, 23, 12, 55. So these are the 5 values of z. Now we'll simply print the df. So there is an error. I have taken here the wrong bracket, so it will be a square bracket. So you can see these are the 5 values which I have taken. So let's take another example in which we will take different data types. So let's make df1 equals pd dot data frame, okay. Now we will take the values inside it. So similarly like before, I am taking a, and then I am going to put the values as 1, 2, 3. These are the 3 values. Here in the b I will take some boolean values. So let's take a true, and then false, and now I will take another as c, and inside that I am going to take some floating point numbers, and let's say 0.45678, and then I am going to take minus 0. And then I am going to take 0.98765. So these are the values, and now I am going to take a index value. Let's say index equals, I will index it as a, b and c. So this will be our index value. Now I will print df1. So you can see the value of df1. So it has taken the index, the value of a 1, 2, 3, the value of b as boolean, true, true, false, and in the c it is taken the floating point value. In this video we will be learning about data frame drop columns. Dataset could be in any shape or form. So to optimize the data analysis, we need to remove some data that is redundant or not required. So we will just drop the column from there. So we will just import pandas as pd. Okay, let's make a student underscore dictionary. So I'll put the values as name, and then let's say the names are Sarmishtha and let's say Devyani. Okay, there are 2 names, and let's say age equals 18 and 19, and let's put the marks also. (86) and 90. So this is our student dictionary. So let's create a data frame student underscore df is equal to pd dot data frame, and then we put the student underscore dictionary inside it. Okay, we can print it, print student underscore df. So you can see the new data frame, Sarmishta and Devyani with age and marks. So let's drop. So student underscore df is equal to student underscore df dot drop, and then we'll be dropping the columns equals, let's say, age. So we'll drop age, we'll print the student data frame. So you can see here the age column has been removed. So now we'll just drop multiple columns. So let me copy this data and we will drop multiple columns. Okay, so I have copied it and I will just do that student underscore df is equals student underscore df dot drop. Okay, and then I'll be putting columns equals, let's say, age and marks. Okay, so I'll be removing here two columns. Let's print the student underscore df. So you can see here only the name column is been left. Now we'll be using the axis parameter. So this will do the same function, but it is very useful. So let's use that. I'll be pasting the same data as above. Okay, and then student underscore df equals student underscore df, then I'll be dropping the age and marks. Okay, age and marks will be removed and I'll be using the axis parameter. Axis is equal to, we'll be removing columns. Okay, and I'll just print the student underscore df. So you can see here the same thing has been done. So you can also remove the, you can also use one also here, so it will be indicating the column. Okay, so you can also use your rows and then you can just specify the index over here, let's say 0th index. So you can see the Sarmishta that was in 0th index is been removed. Okay, so this was an example of axis parameter, and now we will be suppressing the error. So let's say suppressing errors. Okay, so we'll be suppressing the error over here. So what it will do, you can see here student underscore df equals, let's say, student underscore df dot drop. Okay, and then let's say a salary named column is not existing, so we want to remove that. Okay, so column equals, let's say, salary. Okay, salary is not there, so we'll just put error equals ignore. Okay, so this will ignore the error. Let's print the student df, print student underscore df. So you can see here it is showing all the correct data. If we remove this, it will be showing an error. So you can see here it is showing key error. So this was the suppressing of error. Now we will be dropping the column by the index number. So let's do that by using position, drop by index position. Okay, so we'll be using the same data, and then let's see the current values of the columns. Columns dot values. Okay, so here is an end of line error, so I missed something over here in the above So here the so now you can see the column values are being given as name, age and marks. So let's make a variable position equals length of student underscore df dot columns, and then we'll put -1. So this will find the position of the last column and drop it. Okay, so student underscore df equals student underscore df dot drop, and then we'll put the columns equals student underscore df dot columns, and then we'll put the position. Okay, we'll just print the student underscore df dot columns dot values. Okay, so you can see here it has deleted the column present at index 1. Okay, so now let's drop range of columns using ILOC. Okay, ILOC. So we will be using the same data as above. We have pasted the data, and now I want to drop the column from 1 to 3. So let's say student underscore df equals student underscore df, then drop. Okay, and then columns equals student underscore df dot ILOC, and then I am going to put the range from 1 to 3. Okay, I'll print the student underscore df dot columns dot values. Okay, so you can see only name is being left out. So now let's drop the first n columns, first n columns. Okay, so here we'll using the same data and we'll be using the ILOC. Okay, student underscore df equals student underscore df dot drop, and then we'll put the columns equals student underscore df dot ILOC, and then we'll put the range over here. Okay, we'll use the range function, range. Let's put the range as 2. Okay, and then we'll print the student underscore df dot columns dot values. So you can see here only the marks has been left out. In this video we will take a CSV file as input and return a data frame as output. So let's import pandas as pd, and now I am going to make a variable data, and then I am going to put pd read underscore csv. So this read underscore csv will read the csv file. I have a tesla.csv file inside the same folder as this Python file. So I'll print the data. So when I run the program, I can see it is showing the contents inside the CSV file, but by default it is only showing the 5 rows from the top and bottom 5 rows, but there are 757 rows inside this file. I will show you how to increase the rows later on. So now let's see the type of this data. Type of data. So that you can see the type as data frame. Now let's make another variable, data1 equals data dot ILOC, and then let's slice it, let's say 2. Okay, now let's print the data1. So when I am printing it, it is showing the volume column completely. So you can see here the volume column has been printed, but the type is different. Let's see the type of data1. So you can see the type is being shown as series. So let's take another file. I have another file name as state inside the same folder. So I am going to make a variable states equals pd dot read underscore csv, and then the file name as states dot csv. Okay, and I'll just print the states. So you can see here it is printing the contents inside the file. So it is showing the state and the population which is stored inside the CSV file. Now let's see some options of data frame. So as I said earlier, it was by default showing only 5 rows from the top and 5 rows from the bottom. So let's increase the setting. So pd dot options dot display dot max underscore rows, okay, so equals 20. So it will change the settings of maximum rows to be shown. So now let's change the minimum rows. Set options option, and then I'll put display dot minimum rows. Okay, so let's say minimum rows is 12. It will show 12 rows. Let's print the data. So when I'm printing, it is showing 12 rows. So now let's change the setting of this as 200. Maximum will be 200, and let's say minimum will be 100. So it will show the 100 rows. You can see here the setting is being changed and it is showing 100 rows. In this video we will rename the column. So we'll start from renaming a single column. So we'll use rename function over here. So let's import pandas as pd. Okay, we'll make a student underscore dictionary. Okay, I'm going to put some name inside it. Let's say name. Okay, and then I'm going to put Menaka, Rambha, Urvashi. Okay, 3 names are here, and let's put the age 20, 21, 22. Okay, and let's put some marks. (93), (91), and 89. Okay, so this is our student dictionary. Let's create a data frame. Student underscore df equals pd dot data frame, and then we'll put the dictionary inside it. Okay, so our data frame is ready. So let's print it. Student underscore df. So here is a spelling mistake. So you can see here this is our data frame. Okay, now we'll rename the column marks. Okay, let's say student underscore df equals student underscore df dot rename, and then we'll say column equals, we'll change marks to percentage. Okay, so it will be changed. So student underscore, let's print it, print student underscore df. Okay, so you can see here the marks column is been renamed to percentage. So similarly we can change multiple columns also. We'll do that. Okay, so let's change multiple columns. So I am using this example only. So let's change it to C, and name to A. Okay, and age to B. Okay, so let's run the program and see the output. So you can see here all the columns name, age and marks is being changed to A, B and C. Okay, so now we will use a function over here and we'll change the column name. Okay, using a function to rename column. Okay, so we'll copy the above data, so it will save our time of printing, of typing the code. So I'm copying the 3 lines from above and just pasting it. Okay, so now student underscore df dot rename and then columns, and then we'll use str dot upper. So all the letters will be converted to uppercase. So in place equals true. Okay, we'll just print. So you can see here name, age and marks are being converted to uppercase. So now we'll use a lambda function. Lambda function to rename column. Okay, so I am just pasting the above data, and then let's say I am adding here, let's say hash name and then hash age and then hash mark. So what this lambda function will do, this will remove the first character from the column name. Okay, so student underscore df dot rename, and will rename a column equals lambda and then x then 1. So it will remove the first character and then in place equals true. Okay, and then we'll print the student underscore df. So you can see here name, age and marks are being shown and the hash is being removed from the column name. Okay, so now we will remove all columns with a list. Okay, rename all columns with a list. So by using a list we'll change all the column names. Okay, so let's paste the upper data and then I'm going to write student underscore df dot columns, and then I'll put the list. Okay, so I'm putting it student underscore name. Okay, here student underscore age and similarly student underscore marks. Okay, so this will change the column names by using this list. So print student underscore df dot columns dot values. So it will show the column values. Okay, so you can see here the student name is being changed to name is changed to student name and then student age and similarly student marks. In this video we will learn about drop duplicates in Pandas data frame. So data is gathered from various sources. It may not be in a proper form. It contains garbage values and duplicate data. Before analyzing a data set, it must be clean and precise. So here we are going to import Pandas as PD. Okay, let's make a student dictionary which will contain the duplicate values. Okay, so I am going to put here name. Okay, I'll put some names inside it. So let's say Dushasan. Okay, Dushasan, Ashwathama. Okay, and then Vikarna, and I will just repeat the names as Dushasan and Ashwathama. So these are the two duplicate values. Okay, and now we'll put the age. Okay, so let's put the age as 20, 21, 19, 20 and 21. Let's put some marks. Okay, I'm going to put some marks as, let's say, 85.10, 77.80, and then 91.54. okay, then 85.10, 77.80. So these are our 5 values. So let's create a student data frame equals pd dot data frame. Okay, and then we'll put the student dictionary. Okay, student underscore dictionary, and then we will drop the duplicates. So student underscore df, and then drop underscore duplicates. Okay, and we'll just print the student underscore df. So you can see here the duplicate values in index 3 and 4 are being removed. The remaining values are being printed. So now we will drop duplicates from defined columns. So for that I am just copying the above data, so it will save our time. Okay, so here I have copied the data till the data frame. So here the data frame has been ready. Now we'll just drop the duplicates. So I am just writing student underscore df equals student underscore df dot drop underscore duplicates. Okay, and then we'll put the columns in subset equals, the column names are age and marks. So it will look in names and age and marks. Let's print the student underscore df. So you can see here the duplicates in age and marks are being removed. So now we'll keep the last data. Okay, so let me put the comment drop duplicates but keep last. Okay, it will keep the last value. Now I will just paste the data and then student underscore df. Okay, dot drop equals student underscore df dot drop, and then duplicates, and I will just keep the last. Okay, so it will keep the last. We'll print student underscore df. So it will keep the last value. So you can see here Ashwathama is being kept. You can see the above outputs. There the Ashwathama was not present, but here I have kept the last, so it has kept the Ashwathama, that is the 4th index value. So now we'll drop all the duplicates. Okay, so let's drop all duplicates. So here I'll paste the same data. Okay, then student underscore df equals student underscore df dot drop, and then we'll put duplicates, and then I'll keep equals false, so it will not keep anything. Print student underscore df. So you can see here all the duplicates values are being removed, but Vikarna is left out because there was no duplicate value inside it. So now we'll drop duplicates and reset the index. Okay, so drop duplicates and reset the index. Okay, so we'll paste the data, but here we have to make some changes. Over here we'll put the index value also. So I'm going to put index equals, let's say, a comma b comma c comma g. We have to put inside the quotation a and then b and then c and then d and the last one is e. Okay, so these are our index. Now we'll print the student underscore df. So you can see here the index is also been printed with it. So now we'll put the student underscore df, then student underscore df dot drop underscore duplicates. Okay, then we'll keep equals false and then we'll put the value of, just say, ignore index. Okay, ignore index equals true. Now we'll just print the student underscore df. So let's see the output. So you can see only Vikarna is being printed. Okay, and the index is being changed to 0. In this video we will convert Pandas data frame to Python dictionary. So we will be creating different kinds of dictionaries from Pandas data frame. So I am using here a CSV file which is copied in the same folder as this Python file. So we will be importing Pandas as PD and then we'll create a data frame state underscore data frame equals PD dot read underscore CSV and then we'll put the name of the CSV file, that is states dot CSV. Let me print it and show you what's inside it. Print state underscore data frame. Okay, so this is our data. So it contains some state and population. Okay, so we'll be creating a dictionary from it. So state underscore dictionary. Okay, and then we'll put the state underscore df and we'll use the toDict function, to underscore dict. Okay, so this will convert it to a dictionary. We'll print the data. So result dictionary. Okay, we'll just put the state underscore dictionary. Okay, so you can see here it is being converted to a dictionary. So let me convert it to a list now. So for that we'll simply copy the data from above and use the list over here. So the data is the same, we'll just use the list. We'll just use here list. So this will be converted to a list. So you can see here it is now in a list form. Before that it was in a dictionary. Okay, so now we'll convert data frame to dictionary with Pandas series. Okay, so let me put here series and then the data is the same. We'll just change here to series. So when I put the output, so you can see here this is in a series. You can see here the label state, it is in data type object, and then the below one is the population and the data type is int64. Now we will convert the data frame to dictionary without header and index. Okay, data frame to dictionary without header and index. So what it will do, so it will split the input into three parts: row index, column label and the actual data. Okay, so we have the data over here, so we'll just use the split. Okay, split. So you can see here it is in index, row and the actual data. So let me show you the output without using the split. So print. So if we have not used the split, what would have been the output? Okay, list of values from the data frame without index and header. Okay, we'll put an X line over here and we'll just use the state underscore dictionary and then we'll put the data. Okay, so let's print it and see the output. So you can see here this is the output of the list of values from data frame without index and header. So now we'll convert the data frame to dictionary by rows. Okay, data frame to dictionary by rows. Okay, so it is very simple. So what we'll do, we'll use the record over here. So here we are going to just use record. So when we use it, there will be an warning. We will be ignoring the warning. Okay, so now we will convert the data frame to dictionary by row index. Okay, let me do that. Data frame to dictionary by row index. Okay, so here we have the data. We'll just use the index over here. Okay, so let me print it. Okay, so you can see here it is printing with the index. Now we'll convert the data frame to dictionary with one column as the key. Okay, data frame to dictionary with one column as the key. Okay, so here we'll be using the same data but we'll change the keys over here. So you can see here we have the data. We'll just convert it. We have to delete it. Okay, we have the data frame but we'll use here state underscore dictionary. Okay, and then state underscore df dot set index. Okay, set underscore index, and then we'll change it to, let's say, state to population. Okay, dot to dict. Okay, and then we'll do it to population. Okay, now let's print it. Print the state underscore dictionary. So you can see here it is showing like this, Alabama, and then the population. When in this video we'll learn about adding two matrices using nested loop. So we will make a variable x. Inside that I am going to put the values, and then 4, 5, 6. Again we will make 7, 8 and 9, and now let's make another variable y. Inside that I am putting 9, 8, 1, and then 6, 7 and 9. Again 4, 5 and 9. Okay, so this is our matrix. So the result will be zeros. Now I'll make a for statement to iterate through rows. So for I in range and then the length of x. Now for iterating through columns, for j in range length of x 0. Now we'll put the result I comma j equals x of ij and then addition of y of I and j. For printing the result, we'll make another for statement for r in result and then we'll print r. So when we print the output, it is saying it is capital X. So you can see in this video we'll be learning about some important functions of Numpy array. We'll start with as array. It is a function which is used to convert an input to an array. So the input could be list, tuple or nd array. So first we'll import numpy as np and then I am going to assign a is equal to np dot matrix and then I am going to put np dot ones and then 4 comma 4. Okay, now I want to change the second row of the array. So I am going to say a and then 2 equals 3, but when I print it, it will remain unchanged. The value will be the same. So for that we are going to use as array. So we'll put np dot as array and then a and then we'll put 2 equals, let's say 3. Okay, and I'm going to print a. So when I print it, I can see the value being changed to 3. Okay, so now you are already familiar with a range. So a range is used when you want to create values from, let's say 1 to 10. So we can use a range. So I'm going to take an example over here. Let's say np dot a range and then I'm going to say 1 to 11. But when I print it, let's make put a b equals and then I'm going to print b. So you can see it is printing from 1 to 10. So if you want to make it as even numbers or odd numbers, you can put the step value as 2. So it will print all the odd numbers over here. You can see 1, 3, 5, 7, 9. If you want to print the odd even numbers, you can put the same as like this. So you will see the even numbers like this. Now we will learn about reshape data. So in some occasion you need to reshape the data from wide to long. You use the function reshape function. So I am going to make a variable e equals np dot array and then I am going to put the value as 1 comma 2 comma 3 and then let's say 4 comma 5 comma 6. Okay, and now if I print e, I can see the array like this. Now I will reshape it. So I am printing it, print e dot reshape and then I am going to put 3 comma 2. So it will be reshaped. You can see it is like this now, 3 rows and 2 columns. Now we will learn about flattened data. So when we are dealing with some neural network like convnet, we need to flatten the array. So we use the flatten function. So we will take an example of that also. Let's say print e dot flatten. So you can see this is the data 1 2 3 4 5 6, it is been flattened. So now we will see the h stack. So h stack is used when we want to append the data horizontally. So let's take a variable f is equal to np dot array, and then we will put some values inside it, 1 comma 2 comma 3, and let's say another one is g, and here I am going to take another data np dot array, and then I am going to put 4 comma 5 comma 6. Okay, now I am going to print horizontal append. Okay, and then we will put np dot h stack, and then the value f comma g. Okay, so when I print it, I can see the horizontally appended values of f and g. So similarly there is v stack, in that we can append the data vertically. So I am going to say v stack, and then let's say here also I am going to take f is equal to, so the already the values are there, let's print the values, print vertical append, and then I am going to use np dot v stack, and then the values of f comma g. So when I print it, I can see the values appended vertically. Now let's generate some random values. Let's say normal array equals np dot random dot normal. Okay, and then I am going to put some values like 5, 0.5 and 10. These are the three values, and now I'll print the normal array. So let's print it. So you can see the random value has been generated. So now let's see another example of line space. So line space gives evenly spaced samples. So np dot line space. Okay, and then I am going to put 0 comma 10 comma 6. Okay, so let me put it inside a variable, let's say x, and then I am printing x. So you can see it is printing evenly spaced samples. Now let's see log space. So log space returns even space number on log scale. So log space has the same parameter as np dot line space as this. Let's take an example. Let's say y equals np dot log space. Okay, and then we are going to put 3.0 and then 4.0 and num equals 4. Okay, let's print y. So you can see it has been returned the value of evenly spaced numbers on a log scale. In this video we will be learning about converting datetime and datetime objects to its equivalent string. So we will import datetime from datetime. So from datetime we will import datetime, and a variable now will contain datetime dot now. So this will contain the current date and time. I will print now. So you can see it is printing the current date and time. So now we will create a variable here equals now dot str f time, and then we'll put a format code %y. So this will give the year, print year, and then we'll put year variable inside it. So you can see it is printing the year variable. Similarly, we will do it for the current month and current date. Okay, so we'll change the format code for month as M, and then we'll put here month. We'll change here also month, and then here also I am changing it to month. Here the format code for day is D, and then we'll change here to day, and then here also I'll change to day, and here also I'm changing it to day. So when we run it, so you can see it is printing year, month and day also. So now let's do here for the time also. So time equals now dot strf time, and then we'll put the format code as %h, %m, and then %s for second. Now we'll just print it, point time, and then we'll put the time. So you can see it is printing the current time. So similarly we can do it for the combination of date and time. So I am going to print date underscore time. This will be a new variable. Inside that now dot strf time, and then I am going to put the format codes as M, and then for date D, and then for year capital Y, and then R month, R minute. So I am going to put %h for R, for %h for minute, and %s for seconds. And now I'll print the date and time, and I'll just put the date 1, date underscore time 1. So when I'm printing it, so it is giving the output. So you can change here also the format. I'm going to put here M and here D, so you can see the change in the output. So now we will take an example of the timestamp. So let me put a timestamp. Timestamp equals, let's say 166.879 and then 7322. So this is our timestamp, and now we are going to create a variable name date time, and then we will put date time, and then from timestamp, so it is coming here timestamp, and then we'll put the timestamp variable inside it, and then we'll print the date and time, date time object, and then we'll put the date underscore time. So you can see the date and time stored inside the timestamp has been printed. Now we'll use some format code in this also. So let me use some. So D equals date underscore time dot strf time, and then I'm going to put the variables as format code as %m, %d, capital Y, and then for R %f, and then %m, then %s for seconds. I am going to print it as output. Let's say output 2 is D. So when you print it, it is giving, sorry, I made a mistake in the position mark, put it here. So you can see it is giving in the format of month, day and year. So similarly, we'll use another format code, d equals to date underscore time dot strf time, and then I'm going to put percentage small d and percentage b, and then percentage y for year. Let me print the d, print it as output number 3, and then I'll put d. So you can see it is giving here as 18 NOV and then 20 22. So if I print it here capital B, it will give the full November. You can see it is giving November when I change it to B. So now let's do another one. D equals date underscore time and then dot strf time, and I am going to put here percentage capital I and then percentage P, and now I am going to print it as output number 4, output number 4, and then I am going to put here D. So when I print it, it is giving. In this video we will learn to get current time as well as different time zones in Python. So first we will take an example of current time using datetime object. So from datetime we will import datetime, and then I will make a variable now. Inside that datetime dot now, and then current time equals now dot strf time, and then I'll put the format h and percentage m, then percentage s for second, and then I'll print the current time. And then I'll put now current time. So you can see it is giving the current time. Now we'll make a time object. So let me erase this, and then I'm going to create a variable now. Inside that I'm just putting datetime dot now, and then the time object time, and then I'll print now equals, and then now, and let's see the type of this. We'll print type of now. So we'll just print type and then now. So you can see it is giving datetime dot time and then the current time. So now we'll see the current time of a time zone. So let me erase this. So I'll import from datetime, import datetime, and then I'll import pytz, and then time zone of, let's say, New York equals pytz dot time zone, and then I'm going to just put America and then New York, now date time underscore ny equals date time dot now, and then time zone of New York. Now I'll just print ny time and then date time underscore ny dot strf time and then the format percentage s, percentage m and then percentage s. Okay, so let's print it and see. So you can see it is giving the time of New York. In this video we'll be learning about the Numpy data type. So let's import Numpy as np and then we'll make a variable x equals np dot array and then we'll put some integer inside it. Okay, and then we'll print the type of x dot d type. Similarly we will make it for a floating point. So let's put some floating point values 1.4 and 2.0. So when you print it, it is saying int 32 and float 64. So let's make another one. Here I have to change the value as, let's say xf, because this was the floating point. And now here we are going to make a int 64 by putting the value of d dot d type equals np dot int 64. So it will show the value as the 64. Let's say x64 and here also I am going to put x64. So when I do it, it is saying x int 64 value is the data type, and now we will see the random numbers. So let's say np dot random. So here I am going to put np dot random and I am going to say dot random value of 3 to 5. Okay, so let's see the random value. So you can see here an array of random values have been generated. Now let's make some decimal numbers by writing 4,2. So it will show between 4 and 2. And 2. So you can see here the values. Now I will use the value rand n. Okay, so let's create a variable y equals np dot random dot rand n, and then I'll put some values 4, 3. Just print the value of y and you can see the value of an array which is generated. Now we will see the rand int. Let's change it. This is rand int, y rand int, and here also I am going to change it to int, and let's change the value to 2,100 and we will say y rand int. So it is saying it is a problem because there is a mistake. Here it is correct now. So it is saying the value of rand int between 2 to 100 is 77. In this video we will be learning about matrix multiplication. We can implement a matrix as nested list inside a list. So the matrix multiplication of two matrices x and y is only defined if the number of columns in x is equal to the number of rows in y. So let's make a 3 into 3 matrix. X equals, and then I am going to put inside the list 12, 9 and 3. Similarly I will make 4 comma 5 comma 6, and then let's say 7 comma 8 comma 3. Okay, I will close the list, and now let's make a 3 into 4 matrix in y variable. I am going to put inside that says 6, 8, 1 and 3. Okay, now let's add more 5 comma 7 comma 3 comma 4, and here I am going to add 0 comma 6 comma 9 comma 1. I'll close the list, and now I'll make a result in 3 into 4 matrix. So result will be like this: result equals 0 comma 0 comma 0 comma 0. Similarly, like we have done in matrix addition, we'll close the list. Now we'll iterate through the rows of x by making a for statement for I in range of length capital X, and then we'll iterate through the columns of y by making a for statement of for j in range of length y0 and now we'll iterate through the rows of y by making another for statement for k in range of length y. We'll make the result which will increase I j, and then plus equals, I'll put x I and k and multiplied by y of k and j. Now we will make a for statement to print it for r in result, and then we will print r. Now let's run it. So you can see 117, 177, 66 and 75, 49, 103, 73, 38 and 82, 130, 58 and 56. In this video we will learn about a nested while loop. So it is a while statement inside another while statement. So in a nested while loop, one iteration of the outer loop is first executed, after which the inner loop is executed. So the execution of the inner loop continues till the condition described in the inner loop is satisfied. So here we are going to print 1 to 10 multiple times. So I am going to take I equals 1, and then while I is less than equals to 3, then j equals 1, then while j is less than equals 10, so this will print till the 10th value, then I will print j and then it will end. Now I will increment the value of j by 1, and then I will increment I by 1, and then I will print. So when I print it, I can see the values here are printed 3 times. So you can see here I is less than equal to 3 and I was 1, so it is printed 3 times. Now we will print the star pattern as printing pattern. So I am going to take I equals 1, then while I is less than 6. So here if I take I is less than equal to 6, so then it will print 6 times. So here I am just printing I is less than 6, so it will print 5 times. Then j equals 0 while j is less than I. then I'll print star and it will end with a space. Now I'll increment the value of j by 1 and then I'll print and then I'll increment I plus equals 1. So when I print it, I'm seeing the pattern 5 times. So if I put a equal sign here, it will print 6 times. Now I am going to take an example of the same with a for inside a while statement. For inside while statement, here I is equals 1 while I is less than equals 6, then for j in range of 1 to I plus 1, I'll print star and then it will end with a space. I'll print it and then I'll increment the value of I by 1. So you can see the same output is there. In this video we will be learning about the sleep function. It suspends the execution of the current thread by a given number of seconds. So now I am going to import time and then I'll make a while statement, while true, and then I'll make a local time variable equals time dot local time and then result equals time dot strf time, and then we'll put the format codes I, then %m, then %s, and then %p, then local time. Now we will print the result. Then time dot sleep by 1 second. So when we run it, we can see the execution has been suspended by 1 second every time. So now we'll learn about the multi-threading in Python. So a computer program is a collection of instructions. So a process is the execution of those instructions. So a thread is the subset of the process. A process can have one or more threads. So until now we have been using a single threaded programs. So this example will be of multi-thread. So let me stop this by pressing Ctrl C and I am going to erase this. Import threading and then I am going to make a function named print hello and then for I in range of 3. So this will be printing it 3 times. Print hello and then we will make another def print hi. So same here also for I in range of 3 and then we'll print hi. And now we'll make a variable t1 equals threading dot thread and then we'll put target equals print hello and then we'll copy this and same thing will be pasted. We'll change hello to hi and the name here as t2 and then we'll put t1 dot start and then t2 dot start. So when we run it, we can see it is printing hello 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 3 times and hi 3 times. So the t1 and t2 are running concurrently, so you might get the different output. Now we will use the sleep function in the multi-threading. So now I will just put here time dot sleep by, let's say, 0.7 seconds, and here I will put time dot sleep 0.9 seconds. So let's run it. So when we run it, you can see it, the execution is been suspended by 0.7 second and 0.9 second. In this video we will be learning about Numpy array. It is a grid of values all of the same type, and it is a very powerful n-dimensional array object which is in the form of rows and columns. Here we are going to see the 1D, 2D and 3D type of array. We are importing Numpy as NP. We are making a variable x. Inside that we are putting NP dot, and then we'll put range of 2 to, let's say, 6, and then dot reshape, and I am going to put the value as 4. I will print x. So I will see the value of the one-dimensional array. For making a two-dimensional array, I am going to just copy it and change the value here as two-dimensional x2. I am changing the value here as 10 and here as 2, 4. When I print it, I will see a two-dimensional array and now a three-dimensional array. Similarly, we will make a range of 24 and then we will put the value 4, 3, 2, and then we will change the value here as x3. So x3 will show the three-dimensional array. So you can see this is the three-dimensional array. Now we will create a list simply by writing my list equals 1, 2, 3, 4, and now we will convert this list to a Numpy array. So Numpy array from list equals np dot array of my list. We'll simply print the Numpy array from when you print it, we will see the value has been converted to a array. So there is no need to declare a Python list. The operation can be combined. So we will just make a Numpy array from a tuple by making a list. Let's say my list 2. We will make my list 2 equals np dot array, and we will put the range of 1, 5, and then we will print the my list 2. So here is the value of my list 2. Now I am going to make a variable a. Inside that, np dot array of, let's say, 1, 2, 3, and then we are going to print the one-dimensional array a. So this is the one-dimensional array, and we can also see the type of it. Let's see the type. When we see the type, it is saying it is a numpy.nd array. Now I am going to make a list. Okay, let's say we'll make a matrix over here. Let's make a matrix, my matrix, equals 1 comma 2 comma 3 and then 4 comma 5 comma 6 and now 7 comma 8 comma and 9. Okay, so this is our new matrix. We are going to make np my matrix. You will see the value of my matrix over here. When we print it, it will show the values we have put in the my matrix. And now let's make this a np array, np dot array, and then I am going to put my matrix inside is my matrix. Now this is an array. In this video we will be learning more on while statement. I am going to make a variable name. Inside that I am going to put a name Dhritarashtra. And now I will be taking I equals 0, then res equals, let's say, length of name minus 1, and now I will make a while statement. I is less than equals res. Now I will print the name and then I will increment the value of I by 1. So when I print it, it is printing every letter by letter, and if I erase -1 here, I will not be using equal sign here. Let's say I erase this, then the output will be the same. You can see. Now what we will be doing, we will be printing the numbers like this. Number equals 1 comma 2 comma 3 comma 6 comma 7 comma 8 comma 9. So these are the numbers. So I am going to make a variable size equals length of number, and then same I equals 0, and while I is less than size. So here I am not taking the equal sign. I will print number of I, and then we will increment the value of I by 1. So when you print it, it will be printing all the numbers one by one. So now let's take a list with different data type. So I am going to make a variable list equals, let's say 60, then Python, and let's take a floating point number 50.2. Okay, I equals 0 while I is less than 2. So it will only print the first two values, it will reject the last value. So we will print the list of I and we will increment the value of I by 1. So when we print it, it will be printing till Python, and the value of the floating point is not being printed. Now let's print the squares of numbers till 10. So I am going to take while I is less than equals 10. So we are taking equal to sign because we will be including 10. We will print I star star 2, and then we will increment the value of I by 1. So you can see it is printing the squares till the number 10. Similarly we can take the cube also. So here we will not take equal to sign, so it will print till 9. Now we will print, let's say I star I, and then we'll increment the value of I by 1. I plus equals 1. In this video we will be learning about basic mathematical functions. In arrays we are importing Numpy as np, and then we will put the variable a equals np dot array, we are going to put the values as 0, 1, 2, 3, 4, 5, and now when I print it, it will show the values of array A. And now I am going to do some mathematical operations. So when I add 2 to A, it is showing the result as the addition of the elements of A and 2. When I do the multiplication, it will show the multiplied values. Similarly, I can do division also, and we can do like this also. A minus A will give 0. So similarly, there you can do like square also, and then for cube root we will just type star 3, so it is giving the cube root. So there are some universal functions also like square root. So let's print square root, and then we'll put np dot sqrt of, let's say, A. So it is showing the square root values. Similarly, there is exponential also, so we'll print exponential, and then we'll put the value as np dot exp A. So this will show the exponential values. Similarly, we can see the sine and cos values also. Print sine, so np dot sine and then A. Similarly, you can print for cos also, cos, and then we can put np dot array, np dot cos and then A. So this will show the values of sine and cos. So you are already familiar with dot product, so let's do that. So we'll take a variable f equals np dot array, and then we are going to put the values inside as 1, 2. Similarly, we will take g equals np dot array, and then we'll put the values as 4, 5. So the result will be as 1 multiplied by 4 plus 2 multiplied by 5, that will give the output as 14. np, let's say print, and dot product is, and then we'll put np dot f comma g. So this will give the value as 14. You can see the dot product is been printed as 14. So similarly, we can do for different numbers and matrix multiplication also. So we can, let's see an example of matrix multiplication. So let's take a variable A equals np dot ones, and then we'll put 2, 3 inside it. Similarly, we will take another as B equals np dot full, and then we will take 3, 2, and then another value as 2. So let's do the matrix multiplication. Print matrix multiplication is, and then we'll put np dot matmul, and then we'll put the value of A, B. So when we do that, it is saying I missed a L over here, so let me put it. So you can see the matrix multiplication. In this video we will be learning about time module. We'll start with time function, which returns the number of seconds passed since January 1st 1970 to the present time. So we'll import time, we'll take a variable named seconds, and then time dot time, and we'll print seconds since watch, and then we'll write the seconds. So when you print it, we can see this is the timestamp. So let's copy this, and now we'll learn about ctime, so which takes the second past since epoch as an argument and returns a string representing local time. So we'll make a variable seconds equals, and we'll put the timestamp inside it, and then local time equals time dot ctime and seconds inside it, and then we'll print the local time, and then local time. So when we run it, you can see the local time is showing. So now we'll learn about the sleep function, which will suspend or delay the execution of the current thread for the given number of seconds. So we'll print it like this. This is printed immediately. And then we will put time dot sleep, let's say sleep for 1.6 seconds, and then we'll print this is printed after 1.6 seconds. So you can see it is saying this is printed immediately, and then after 1.6 seconds the next line was printed. So now we'll learn about the local time function, which take the number of seconds passed since epoch as an argument and return a struct time object in local time. So we'll see, we'll take a result equals time dot local time, and then we'll pass the timestamp, and then we'll print result, and we'll put the result inside it. Again we'll print the year, and then we'll put the result dot tm underscore year. Now for the R we'll put T, let's say TMR HOUR, and then we'll put result dot TM underscore R. So when we run it, we will see the output as the result dot TM here, and then the TMR. Similarly, GM time function takes the number of seconds passed since epoch as an argument and return the struct time in UTC. So in this example only we are going to just change this to GM time, and we can see the output. We can see it is showing the output in UTC. Now we'll take the example of strf time. So strf time function takes struct time as an argument and returns a string representing it based on the format code used. So you remember the format code in the last videos, so we'll use that in this. So let's say in comment this is strf time function. Now we will make a variable named tuples equals time dot local time. This will get the struct time, and then we'll put time underscore string equals time dot strf time, and then we'll put the format codes for month, for date D, and then for year Y, percentage capital Y, and then similarly we'll do it for percentage hour, percentage minute, and then percentage second. Okay, and then we'll put the named tuple. Okay, now we'll print the time string, time underscore string. So when we run it, you can see the output. Sorry, I have put here the quotation mark, which is not necessary. So you can see the output, it is giving the current date and the time. Now we will learn the strp time. So this function passes a string representing time and returns a struct time object. So let's do that. strp time function. Here I am going to take time underscore string equals, I am going to take today's date 10 August, and then I am going to put 2022. Now the result equals time dot strp time and then the time string, and then we'll put the formats percentage d, then percentage capital B, and then year percentage capital Y. Now I'll print the result. So you can see it is giving the output in struct time object. In this video we will be learning about array indexing. Numpy offers several ways to index into arrays and changing specific elements, rows and columns. So we are going to import numpy as np equals np dot range of 0 to 11. So when we print it, we will see the value from 0 to 10. So similar to Python list, numpy array can also be sliced. So let's index a 1D array, let's say 2. So it will show the value of the second value. Now I am putting 1 to 4, so it will show from 1, 2 and 3. Let's change this to 6, and then here nothing. So you can see from 0 to 5 it is showing, and when I put here 3, it will show from 3 to 10. So now let's slice it. I am going to make a variable as slice of a equals a 0 to 5, and I am going to print the slice value, slice a. So it will show the value of the newly sliced array. Now let's make the change here, slice underscore a, and I am going to change all the values of the array to 100. When I print slice a, it will show all the value will be converted to 100. So when I print a, some values will be changed. So you can see some values are changed and the original value is as it is. So let's make a copy of a underscore copy equals a dot copy, and when I print a copy, it will contain the value of the a. Now I am going to change the value of a copy to 200. So let's do it, a underscore copy, and then the whole value will be changed to 200. Print a underscore copy. So whole values is converted to 200, but the original value is the previous one. So you can see the original value. So we must be always careful when copying the array. So let's make a new one, np dot array, and let's say here I am going to put the new values as 1, 2 and 3, and then I am going to copy, let's say b equals a, and then it is similar to b is equal to a dot copy, but I have used b is equal to a. Let's say b0 equals 100. So the first value will be changed. When I print a, the value of a is changed. Like you can see here, the first value is being changed to 100. So now let's index a 2D array, that is matrices. So let me create a variable named mat and then put inside it np dot array, and I will put the values 5, 10, 20, and then I am going to put 20, 25, 30, and again I am going to make a new one. Here I am putting 35, 40 and 10. Okay, so this is our new matrix. So I am going to print match. So when I print it, I can see the new matrix. And now let me index it. Let me put 1 here. So I can see the first value of first row 20, 25 and 30. I am going to put 2 here. So I am seeing 35, 40 and 10. So we will get a individual value by putting mat, let's say 1 and 1. So we will get an individual value, that is 25. Let's change it to, you can write it like this also, 1, 2. So when we write like this, I have to put a square bracket in the end. The individual value has been printed as 30. Now let's slice this. Let's say 0. So it is showing 5, 10 and 20. And now let me do this 1 and then comma and then 2, like this. So you can see it is being sliced from bottom left corner 2, 2. Now let me shape the bottom row. The bottom row, you must see it as, this is the bottom row, 35, 40 and 10. Now I am going to change this to 2, this. So I can see it's the same value is been printed as the bottom value. Now I am going to make a variable a equals np dot array, and then I am going to put the new values over here, 1, 2, 3, 4, 5, 6, 7, and then in the next one I am going to put some 8, 9, 10, 11, 12, 13 and 14. So this is my new variable a. I am going to print the value of a. So when I print it, I am seeing the new values. So we will get a specific element by putting the row and column. So I am going to put 1, 5. So I can see the value 13. So similarly, we can get a specific row also by printing 0 to this, so colon. So I am getting the whole value of the row. And for all the columns, we can put like this, just changing it to 0, and here a colon. So it is showing 1, 8. Now getting a little more fancy, we are going to put the value as 0, 1, no, let's say 1 semicolon -1 and then 2. So when I do this, I am getting the array of 2, 4 and 6. So similarly, I can get the value as I have done in the first case, 1 to 5. So this is the value of 1 to 5, and now I am going to change it to here, let's say a, and then I am going to put 2 equals 1, 2. and then when I print it, I'll see the value as the same. You can see 1 2 3 4 5 6 7 to 14. In this video we will convert timestamp to datetime object and datetime object to timestamp. So timestamp is basically the number of seconds between a particular date and January 1st of 1970. So let's convert the timestamp to a datetime object. So we'll import datetime from datetime, and then we'll create a timestamp equals 16657300073, and then we'll create a datetime object variable, and inside that datetime dot from timestamp, and then we'll put the timestamp. Now we'll print the datetime object equals dt object, and let's see the type also. Type of datetime object, type of dt object, and then we'll put the type of dt object. So when we run it, you can see it is printing the date and time which is inside the timestamp variable, and then the type of the dt object. So now let's create a timestamp. So you can create a timestamp from a datetime object using datetime dot timestamp method. So let's do that. Let's make a variable now equals datetime dot now, and then we'll make a variable timestamp, and then datetime dot timestamp, and then we'll put now inside it, and we'll print the timestamp equals timestamp. So you can see the new timestamp has been generated. In this video we will be learning about transposing a matrix. So if a matrix is 3 into 2, then the resultant matrix will be 2 into 3 matrix. So let's make a matrix X equals, and the value will be 12, 9, and then we'll put another value 7, 3, again we'll put another value 5, 6. Okay, so this is our new matrix, and the resultant matrix will be result equals 0, 0, 0, and then again another one will be 0, 0, 0. So this will be our resultant matrix. So first we'll iterate through rows by using a for statement, I in range of length of x. Now we'll iterate through the columns, for j in range of length, and then we'll put x0, and result ji equals xij. Now we'll print the result for r in result, and then we'll use print r. So when we print it, we can see the output as 12, 7, 5, 9, 3 and 6. So this was using nested list, and now we'll be using list comprehension. Let's say list comprehension. Okay, so we'll make a matrix similar to the above one, 12 comma 9, and then we'll put 7 comma 3, and then 5 comma 6. Okay, so this is our matrix, and now we'll put the result variable equals x of j and I for j in the range of length x, length of x, and then we'll close the brackets, and then we'll use for I in the range of length x and 0. Okay, and we will close the brackets, and now we'll use a for statement for printing the result for r in result, and then we'll print r. So you can see the output is same. So here we have used nested list comprehension to iterate through each element in the matrix. In this video we will be learning about passing the variable number of non-keyword arguments to function and variable number of keyword arguments to the function. So let's take an example. I am defining a function named addup, and inside that I am going to put x, y and z. So there are 3 arguments in this function. So I am going to print the sum, and then I will add x, y and z, x, y and z. Okay, and now if I call the function and put the arguments like this, so when I will run the program, it is saying there are 9 arguments, but it can only take 3 because we have defined here 3 arguments. So first we'll take an example of non-keyword argument. So this will take multiple non-keyword argument. So let me take an example of this. So I'm going to create adder, and it is defined by the star and then the argument, then sum equals 0 for n in num. I will add sum equals sum plus n, and then I will just print the sum. Now I will call the adder and put some variables. Here there are 5, and then here I am going to take multiple arguments. So when I run it, so you can see it is taking multiple non-keyword arguments. So now we will take the example of multiple keyword arguments. Keyword arguments. So like above example, we will just put double star in this intro, and then double star data, and then we'll print the data type of the argument /n data type of argument. Okay, and then I will just put the type of the data. Now I'll make a for statement for key and value in data dot items, and then I will print is, and then dot format key and value, and now I will call the intro function intro, and I'll put some keywords inside it. So I'm taking first name equals, let's say, Subhadra, and then I'm going to take the age equals 24, and phone equals 888-1212. Now I'll just copy it, and again I will call this and change the data inside it. So first name I am going to take as Draupadi, let's say age is 42, phone number is 4242, and I am going to add email also inside it. Email is equals panchali@gmail.com. So when I run it, so you can see first it is giving the data type of the argument, which is dictionary, and then it is printing the name, age and phone number. In this video we will be learning about anonymous function. So anonymous function is a function that is defined without a name. It is also known as lambda function. So we are going to take an example of even numbers. So I am going to create a list named L equals, I am going to put some values inside the list. You can see some values are there inside this list, and then I am going to make a variable even numbers equals, and then I am going to write list and then filter. So this filter takes a function and a list as an argument. So I am going to put the function as lambda of x %2. So this will search for the even number equals 0, and the other one is the list L, and then I am going to print even numbers are and then I'll put the even underscore nose. So you can see the output, it is showing the even numbers. So let's take another example of double equals lambda x star 2. So it will multiply the number by 2. So I'll print the double of, let's say 10. So it will give 20 as the output. So here is an error. So you can see it is giving 20 as the output. So there are many examples of this. So I am going to use map and reduce also. So let's take the example of a map. So map takes a function and a list. So you can see I am going to make a list name my list, and then I am going to put some value inside it. Let's say 1, 6, 7, 3, 45, 76, 90, like this. And then I'm going to make a new list equals list, and then I'm going to use map and then lambda x star 2, and then the my list, and then I'll print double values are, and then I'll print the new list, So you can see the output. All the values are multiplied by 2. So again, I'll take an example of cube. Let's make some cubes. So list 1 equals 2, 5, 7, 89, 90, 100, and let's say 170, like this. And list 2 is list of map and then lambda x then star x star x. So this will give the cube and it will be stored in list 2. So I'm going to put the list 1 here and then I'll print cube values are, and then I'll put the list 2. So you can see the output, it is giving the cubes of the values in the list 1. So now I'll use the reduce function. So reduce function is used to minimize sequence elements into a single value by applying the specified condition. So the reduce function is present in the func tool. So we'll import it from func tools, import reduce, and then I will make list 1 equals 20, 78, 54, 67, 89, 90, and then 102, like this. And then I'll make a variable add equals reduce of lambda x comma y, and then I'll make x plus y, and then the list 1 I'll print addition of all list elements is, let's say I'll put add. So you can see the addition is 500. In this video we will be learning about iterator. Iterator is simply an object that can be iterated upon, an object which will return data one element at a time. So we will use next function to manually iterate through all the items of the iterator. So we are going to make a list, my list, and then we'll put some item inside it. We have 4 items inside this list, and we'll create a iterator using iter equals iter, and then we'll put the my list, and then we'll iterate through it using next. So we'll print next and then my iter. So let's copy this and again we'll put that. So we can also use next object like this, print my underscore iter, and then we can use next, and then we'll copy this, we'll use my iter, and again we'll paste it. Let's run it. So you can see it is printing all the items, but if we'll put one more print, it will give stop iteration. So you can see there is an error because the items in the list are finished. That's why it is giving this error. Now this can be done by a for loop itself. So let's say element in my list and then we'll print the element. So when we print that, you can see it is printing all the items by using for loop. So now we'll build a custom iterator. So let me erase this and clear this. So we will be making a class power of 2, and then we'll define init self comma max equals 0, and then self dot max equals max, and we'll also create iter. This is the iterator self, and then self dot n equals 0. It will return the iterator object self. Now we will define the next, and then we'll put a if self dot n is less than equals self dot max. Then we'll make a variable result equals to star star self dot n, and then self dot n will be incremented by 1, and then we'll return the result. Now else statement will be raising and stop iteration. Now we'll create an object numbers equals pu2, and we'll put 4 inside it, and we'll create an iterable from the object I equals iter, and then the numbers. Now we will use the next to print the next iterator. So print next of I. So let me copy and paste it. So you can see it is giving 1, 2, 4 and then 8. If I print it once again, so it is giving 16 also. Now again one more time, so it is giving stop iteration. So this can be done by for statement itself. You can see that for I in POW to, let's say 5, and now we'll print I. So you can see it is printing till 32. In this video we will be continuing with Python generator. So it is a function which returns a generator iterator, just an object we can iterate over by calling yield. So we are going to define a function called simple generator, and the argument will be numbers, and then I equals 0 while true, and then we'll make a variable name check, and we'll ask user for the input, and we'll say, do you want to generate a number? And then if yes, press Y, else press N. Now we'll make a if statement if check in capital Y and small y, and len of numbers is greater than 1, then yield number of I will be incremented with 1, and then else will print by, and then we will put a break. And now I'll make a for statement for number in simple generator, and I'll put some numbers in it, 10, 11, 12, 13 and 14, and then I'll print the number. So let's see the output. So you can see it is asking for the user input. I say yes, so it is printing 10. The next time it will print 11, again 12, 13, 14. In this video we will revise Numpy, Pandas and Matplotlib. So we are importing Numpy as NP. Let's import Pandas as PD, and from Matplotlib we will import pyplot as PLT. So let's put percentage matplotlib inline. So let's make a dataset. Okay, we'll load the dataset pd dot read underscore csv. So we have a csv file in the same folder as this Python file, that is our desktop. So its name was admission. Okay, admission underscore predict dot csv. So now we'll return rows and columns from the dataset. So let me print df dot shape. You can see here 509, that is rows and columns. So let's see the head. Okay, we'll print df dot head. So you can see the top 5 rows and the columns also. It is here the scores, GRE TOEFL score. So now I will return the tail. So let me print df dot tail. So let's run it. So you can see the last rows, last 5 rows. Okay. So you can see here serial number of the student, GRE score, TOEFL score, CGPA, research, chance of admit, and then let's see the object with all the written column headers. So we'll print the df dot columns. So here are the columns complete. So now we will let's see the info. Okay, df dot info. So this is the info. Data type float, int and memory usage is 35. Okay. So there are many things also. There are 500 chance per admit. Similarly, 500 entries. All the things are been printed. So let's return the basis statistic. So I am going to print df dot describe t. So statistics on numeric columns are being printed. So let's see the data type of each column. Let's print the df dot data type. Let's run it. So you can see serial number is int64. Similarly, scores are also int64. Other than that, chance of admit is in float 64. So let's return the column for null values. So let's say df dot is null dot any. So let's run it. So you can see here all are false and data type is boolean. So let's rename the column with appropriate name. I'm going to print before printing, let's change the name, df dot rename function column let's change the GRE score to just GRE. Let's put the quotation mark. So let's see the head. So you can see the change name. So you can see the GRE score is being changed to simply GRE. So I am going to do data visualization. So we have already imported our matplotlib, so we'll use it over here. So let's make a figure variable, and I'm using here the column name from the data frame. So our data frame is already there, df, and I am going to take here the column GRE. Let's put the width as 0.7. Now we'll make a title for the plot. Okay, title. So I'm going to put here distribution of GRE scores. I'm going to make the x-axis, so x label, it's PLT x label. So we'll just put here the GRE scores for the x-axis, GRE scores, and for y label, let's say we'll put here count, and let's print the graph. So plt dot show. Let's run it. So you can see over here the title is there, distribution of GRE scores. Similarly, you can see the x-axis and y-axis also. So let's see for TOEFL score also. We will just copy and paste it over here. We are just changing here to TOEFL. It's TOEFL score. And let's put here TOEFL. And we are also changing it to TOEFL. So let's run it. So you can see another graph, distribution of TOEFL score. X-axis is changed, y-axis also there. So we can change most of the things over here. So let's change over here to SOP, and here also we are going to change to SOP, and we are going to put here SOP weighting. So let's run it. So you can see here distribution of SOP also. So visualizing feature are there, we can change it for everything. For CGPA also we can do that. Let me put for CGPA over here, CGPA, and here we are going to just put the CGPA, here also CGPA. Let's run it. So you can see the values in the x-axis is 7.5, so it is stating from the data frame, and the y-axis also you can see 0, 20, there is a difference of 20. So now we will see last one, as let's say we will take a research column also. Let's take over here so we can understand how the graphs are being prepared. Let's put here research, and here also I am going to change research, and here it will be count. So let me put in small, and here we are going to change distribution of research papers. So let's run it. So this one is a little different. So you can see here the maximum is 2.0, and the count and research is there in y and x axis. So distribution of research paper. So let's import
numpy as np, and we are also going to import our pandas as pd. So these are our important libraries. So we'll import our matplotlib later on. So I am going to load the dataset. So let's say read underscore csv, and I have a CSV file name hard.csv in the same folder. So let's see the rows and columns of this data frame dot shape. So let's run. So you can see that 303 rows and 14 columns. So let's see the name of the columns, df dot columns. Okay, so you can see the name of the columns. So let's print the data types of this df dot data types. So it will print all the data types. So we'll pick as float 64. Similarly, I am going to use a head. So let me see the first 5 rows of this data set. So you can see it is giving the first 5 over here, first 5 rows. Similarly, we can also print the tail, df dot tail. So it will print the last 5 rows. So let's use the isNull method to see if there is any null value in the column. So df dot isNull any. So it is giving all the values as false, none of the value is null. So let's see the info of the columns. So df dot info will print all the information. So you can see here all the information, data types and all. So let's use the describe method to see the basic statistic. df dot describe dot t. So this returns the basic statistics on numeric columns like the standard deviation, max value, mean, count, etc. So now we will see the data visualization. For that we will be importing our matplotlib. So let me comment data visualization. So I am going to import matplotlib dot pyplot as plg matplotlib. Okay, matplotlib dot. So now I am going to also import cbon as sns. So I am going to create a new variable figure. So let me call plg dot figure, and let's put the figure size, and let's say 15 comma 15. Okay, so now let's make a variable ax and we'll use cga. Okay, so g equals df dot ax equals ax. So let's run the program and see the output. So it is taking a little time because there are many graphs. So it is printing one by one. So you can see over here all the graphs. Okay.